right, thank you so much, Aaron, for taking the time to come and talk about your team's work with AxSTREAM and with SoftInWay in general. But before we get into the meat and potatoes of what we want to talk about today, I kind of want to just throw it to you, let you introduce yourself and your team's work before we head into anything else.
Yeah, hi, my name's Aaron. Just graduated mechanical engineering. And we were working a lot with SoftInWay on this really cool turbomachinery project that I'm excited to talk to you about today. So our main goal with this project was just to learn as much as we could about turbomachinery. We have a university rocketry team. We've built pressure-fed liquid rocket engines for a long time. We always kind of joked and wondered about building a turbopump. It's a big challenge for an undergraduate group, but we decided to take it on and see how far we could get. So we did this full detailed design of this demonstrator turbopump. We're using a gas generator to feed a gas turbine, and then we're pumping water to simulate the workload that that pump would have in an actual rocket engine. And our goal was to build and test as much of that system as we could.
Awesome. And yeah, if you could kind of just tell us, what was the first inspiration about this project, why you guys specifically wanted to do this?
Yeah, I mean, if you want to build rocket engines that are capable of putting some substantial payload into orbit, you need turbopumps to feed their propellants into that engine. So all your modern space companies, SpaceX, Rocket Lab, Blue Origin, they're all investing lots of money and research into turbomachinery because it's a really key technology, but it's also really challenging because of the performance that's required and the margins that are available. So it's this really ripe area that a lot of work is being done on. It's really interesting, really challenging. I think a lot of people view it as really important for that reason. And so we decided that we wanted to go kind of right for the coolest thing that we could work on there. So that's why we chose this project.
Yeah, and with turbo pumps being a pivotal piece of turbo machinery, now and going forward in the future, I guess we can kind of shift towards the AxStream software. With your team utilizing it, what was kind of the onboarding with it? What was that process like for you guys?
Yeah, we had a pretty good experience with getting acquainted with it. We found out about it just kind of researching different turbomachinery software packages during the early phase of our project, found the website. We decided to reach out, and we were really lucky to be sponsored by you guys. It wasn't the only software that we tried. We tried quite a few, but it was the one that really stood out to us as really capable and really easy to use. So the onboarding, there's a lot of documentation, there's training, there's courses, there's lots of cool case studies, which are just online. You can go look at those. Those are really cool. And the team was able to communicate with us to answer all of our questions the whole time we were using the software. We found that the software package in general was like this really big, capable, could be very sophisticated, but it was broken down into kind of bite-sized pieces that were manageable to learn. So we found that it was really straightforward to kind of get it to do what we needed to do. So we enjoyed that.
Mhm.
We also thought that it was really well interconnected. There's all kinds of different design modules that it has. And so the integration between these design phases from the preliminary design to the sort of 2D streamline analysis to tuning, iterating designs, and then exporting the geometry, all of that was pretty simple. All of the most time consuming parts were sort of taken care for us by the software. So we really enjoyed that.
Yeah, and I think that's something that we hear a lot from clients and other students like yourselves is we've taken pride in our integrated system, being able to shift seamlessly from module to module, being able to export the geometry as seamlessly as possible. So great to hear that that you guys had that experience. But in terms of maybe shifting back to the project now, I guess were there any snags or any issues that you guys had throughout that you had to deal with, and what was your experience like? Maybe not just with the software, but just with the project in general.
Yeah, I mean, like I said, it's a really big project. Turbomachinery, not surprising, can be quite complicated. With the software itself, we kind of found it overwhelming to even start designing turbomachinery at first. But we looked at a lot of textbooks and kind of had these preliminary designs that we were working with, and then to sort of take all of the different parameters that we could explore, pressure, temperature, speed, diameter, and turn that into a actual design that we were going to pursue was really difficult. AxStream made that easier for us because we were able to explore a lot of designs quite quickly. They have the Monte Carlo simulation, which we used a lot to sort of explore the whole parameter space, which was really cool. We kind of picked a few different directions that we wanted to work in, evaluated those, did our studies, and then we picked the best ones that kind of worked for us. And yeah, I could talk lots about all the other really challenging things about turbomachinery, high speed rotating machinery, really tight tolerances and large loads. So there was a lot of work and research that we had to do there. And a lot of the literature is not publicly available. So figuring out what we need to read to even know how to design things was often a challenge. And again, their AxSTREAM kind of had a lot of even papers cited in their documentation, which I really enjoyed. So we could kind of get going from there.
Mm-hmm. It's great to hear that you utilize a lot of the resources that we have on hand to, enhance your process, with the AxSTREAM software. So that's great to hear. But in terms of the current development, are you guys still working on it? Where are you guys with the process? Did you finish up already? What is that looking like?
Yeah, so we're done pretty much all of the detailed design work for most of the big components of the system, including the final designs for the pump and the turbine. The pump has an impeller and the inducer. So all of those designs are kind of done. Right now, we're actually in the process of heat treating the Inconel stock to build the turbine rotor. So I'm really excited to see that part once it gets finished. So we built a lot of hardware and we've done a lot of testing of all the sort of different mechanical and electrical components of the system. The original group that was working on this project, which includes myself, we've all graduated now. So we're kind of handing off this project to the next generation of students on the Waterloo Rocketry team, but they'll still kind of be in this build and test phase going forwards as we try to validate all the different designs that we've created for the foreseeable future.
Mm-hmm. Something I want that you said that I want to go back to was essentially, taking in AxStream's capabilities kind of in bite-sized pieces. I guess if you could kind of shed some more light on how you guys, maybe not just you, but also the other people on your team, maybe learned about the software through that. Was it through your courses, or how did you guys do that? Maybe on your own as well? How did that work?
Yeah, I think it was kind of a mix of all of the different resources that are available. So we started out with just like some of the articles that are available online because those are easy to access. And then there might have been one or two things where like, okay, like not quite sure how we should proceed with this. So we would send emails to the team. We had a few calls with the team. We tried not to occupy too much of their time, but I'm sure they're very available. But we were able to get a lot of information between what was online and what we could get kind of talking face to face to a person. And so some of the modules in the software that are it for the sort of initial design of the system were pretty straightforward to use. So we didn't have to, it was quite intuitive. But some of the more complicated ones, when you're getting into like the 3D design of experiments or like checking off nominal performance, we needed to get a bit more guidance on how to use some of those parts to their fullest potential. So that's when we kind of reached out to the team to figure out how to use those modules.
Gotcha. Awesome. In terms of yours and maybe your team's view on the turbomachinery sector and maybe this specific technology, I guess, how has your view shifted on designing turbomachinery, designing turbopumps after this process? Has it changed at all, or how have you guys grown through this process, I guess?
Yeah, I mean, the first thing that comes to mind when you ask that question is Dunning-Kruger, right? You don't know what you don't know. And so going into it, we knew that turbomachinery was complicated, but until you actually dig into the details of it, you can't comprehend just how complicated it is. And for our project, we had a lot of constraints that were sort of, I won't say artificially, but we could kind of set our own goals and directions for the project. So like our design does not have to fly. It doesn't have to run for very long. It doesn't have to be reliable. And even with all of those, kind of things that we made easier for ourselves, I can't even imagine how difficult this would be for like actual functional turbomachinery. So it was really eye-opening to see just what goes into designing this kind of stuff and how complicated it can get. And so even though we picked kind of one of the most simple implementations that we could think of for something that qualifies as turbomachinery, it was still the most challenging project I've ever worked on in my life. And we all learned a lot from it. So it was a really enjoyable experience overall.
Yeah, and I guess through that challenging process that you guys endured, were there any sort of specific moments or maybe anecdotes you can share about milestones or things you were proud of throughout the process?
Yeah, I mean, one of the highlights of the process or the project, sorry, was the subcomponent testing that we did. So we spent a lot of time in design, kind of in the trenches there, looking through all kinds of research literature and textbooks and software. And finally, we have this design that was like, okay, let's build it. We can test it. Building it required a lot of trial and error. There's a lot of complex parts that need to be manufactured with tight tolerances, but we were able to get most of that done and move into subcomponent testing. So we used a really big motor to sort of spin up all the different designs for all the major mechanical components of the system, and we evaluated their performance. So things like the bearings, dynamic seals, couplings, shaft, rotor dynamics, high-speed sensors, all of these things that all need to work perfectly. We spun them up to the design speed of 30,000 RPM, and pretty much everything worked perfectly on the first try, which was honestly a little surprising, but really cool. So all of those sort of designs that we worked really hard on that will kind of, they sit in between the pump and the turbine, but all of these parts are critical for the functionality of the whole system. We were really quite happy to see how well our designs had worked. Another really cool part of the project was actually the manufacturing for the pump and the turbine. So, a component on the shaft, like a spacer or something, you can manufacture with a manual lathe. It's not that hard. But the geometries for like the pump or the turbine are really quite complicated. So one of our other sponsors for the project helped us with some Metal 3D printing work. So most of the manufacturing work for the turbine stator is done there. It's printed in Inconel. That design was generated mostly by AxSTREAM. And then we also have done the manufacturing now for the rotor and the stator for the pump. Those are 3D printed in aluminum. So seeing all those really complex geometries come to life, manifest in actual physical metal was a really cool part of the project. One of my favorite parts. So they look really awesome, and we wouldn't have been able to design them without this software.
Mm-hmm. And for, a lot of students kind of coming into school and maybe watching this and saying, hey, that's a technology that I want to, start to build and start to, make more efficient. You know, can you tell them what exactly the day-to-day process looks like? You guys trying to do a little trial and error like you were talking about, but just what that looked like just for them.
Yeah, I mean, it depends on the day for sure. The beginning of the project, like I mentioned earlier, was really research focused. So there's a lot of days just, in the library or whatever, computer lab, just kind of reading through research papers, talking about things, and kind of figuring out what someone meant when they wrote something, which is challenging sometimes. And then in the middle of the project, a lot of work on trying to fit everything together into a really small space with all these different constraints, and then going and actually building that. So I really like this kind of work because not every day is exactly the same. Depending on what you're doing, you can kind of get some variety. Grass is always greener, so that was really nice. But in an engineering career, there's so many different things that you can work on, and we were able to touch all of them with this project, which was really quite cool. But my advice to people who are looking at doing projects like this is don't psych yourself out, even though it looks hard, and it is. You can just pick up books and teach yourself things, and obviously there's lots of incredible resources on the internet and wherever, like SoftInWay, that you can do quite a lot with. So we're really fortunate to have all of that.
Yeah, and you now heading into the workforce, having this experience, I guess, what do you take from this project and this process that you are going to, use in the future? Maybe separate from the software, but also, do you hope to use the software in the future for other similar projects if you do embark on any?
Yeah, I mean, I would be very happy if I was able to continue using this software for my career. It was really great. I think it's definitely one of the most competitive ones in the industry. Something that we noticed with a lot of the other software packages is they were pretty generic and maybe not super geared towards rocket propulsion specifically. Like some of the other softwares could design like a normal hydroelectric generating turbine, but not like a centrifugal, like really optimized like hydraulic turbine like we want to use for a rocket pump. And similarly for the turbine, they could have some sort of generic, airplane gas turbine engine compressor, but not the kind of turbine that we want for a rocket engine, which is like a partial admission, impulse design, really specific niche for our needs. So that was one of the things that we really enjoyed about this software. It was really geared specifically towards rocket propulsion, and it's reflected in a lot of their documentation. So yeah, I would be really happy to use the software again in the future. I think two of the things that I learned a lot about from this project were one, like working on a really complex group project with a bunch of different people that has a bunch of different sort of interdependencies. Like there's mechanical aspects, electrical aspects. Everything has to be integrated together quite tightly, and learning how to communicate with people to facilitate that was challenging but rewarding. And I hope to continue to hone that skill. And also, I'm so sorry.
No, 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 you're
Oh,
good. I think we can stop with that. I think that was a great answer.
sure.
Just the last one before I let you go. I know you touched on it earlier about, not wanting to bother our team and kind of that process as well. But if you could just kind of tell people, exactly what your experience was like communicating with the SoftInWay team, Was it a positive experience? Were you guys able to get answers quickly? What was that like for you?
Yeah, so we had a really good experience communicating with the SoftInWay team. They were always pretty quick to respond, and their answers always, of course, like addressed our immediate problem. But there was also a lot of information, guidance provided about how to use the software better, maybe highlight features that we weren't aware of, and that all kind of made our lives easier as we sort of climbed the learning curve of the software. So overall, we had a really good time communicating with the team.
So yeah, you used AxStream for your gas generator turbo pump as part of your engineering capstone project. Can you just share how the software supported your design process, and were there any specific aspects or solvers that really helped you?
Yeah, I mean, so at the beginning of the project, we didn't actually have our AxStream sponsorship yet. So we were using a lot of like textbooks, very simple 1D equations to come up with rough designs for our pump and our turbine. And concurrently, other parts of the system depended on those designs. So we were kind of in this space where we didn't really have a solid design. We had a rough idea, but then we got the software. Those equations alone were not enough to make a detailed design. But once we got AxStream, we could predict actual performance, create geometry, that sort of thing. And so we used that software to create the full detailed engineering designs for the gas turbine and the pump elements, so the inducer and the impeller. And then once we had those designs, we could explore sort of off nominal performance. What's our margin of safety on cavitation? How do the axial loads on the system change as we vary the flow rates? That kind of thing. That was something that we found that was not done by other software packages. So that was really helpful. And then once we had those detailed designs done and we had kind of analyzed all of our performance cases, we were able to really easily create the rotor geometries and export them in a way we liked into the CAD packages that we were using. So that would have been a really difficult CAD model to create, but AxStream made it really, really easy for us to do that.